Hello, this is DVB. I tutor logic and philosophy. Today we're going to talk about how we can get the symmetry and transitivity of identity from the reflexivity of identity and Leibniz's law. So by symmetry, we can think of it as an inference rule, the symmetry of identity, and it says that if we have a sentence of the form A equals B, we can go ahead and switch around the B and the A, and the resulting sentence will be true if our premise is true. So from any sentence of the form A is identical to B, we can infer that B is identical to A. All right, and transitivity, we could say that if A is identical to B and B is identical to C, then we can go ahead and infer that A is identical to C. Okay, so what we're going to show is that the symmetry of identity and the transitivity of identity, which are expressed here as inference rules, we can derive them actually from two arguably more fundamental inference rules. The first one's called the reflexivity of identity, and this says that on any line we can always infer that any sentence of the form A is identical to A is true. And this embodies the idea that any object you pick, whether it's Socrates or Napoleon, it's true that Socrates is Socrates and Napoleon is Napoleon. So that's the reflexivity of identity. And now for Leibniz's law, we'll go ahead and express it as LL. And this says that from any sentence of the form A is such and such, so the Greek letter phi represents some corresponds to, you can think of it as it corresponding to some attribute of A. So if A has such and such, and it's also true that A is identical to B, well, the only way that A is identical to B and A is such and such is if B is such and such as well. So this perhaps will be more intuitive if we consider an example. So let us abbreviate Charles Dodgson's name with D. Let us also abbreviate Lewis Carroll's name with the letter L. Let us also abbreviate the title of Alice in Wonderland, the novel, with the letter A. And let us also abbreviate the relationship of being an author of with the capital letter A. So this says, for example, whatever we put in the blank here, it says that that thing is the author of whatever we put in for the dotted lines. Okay, so now let's consider an example of how Leibniz's law can be employed. So let's say that Lewis Carroll is the author of Alice in Wonderland. And suppose it's true, because it is, that Lewis Carroll is Charles Dodgson. Well, the idea is, if it's true that Lewis Carroll is Charles Dodgson, then we can go ahead and replace the name Lewis Carroll with the name Charles Dodgson, and the resulting sentence will be true if the premises are true. So if it's true that Lewis Carroll is the author of Alice in Wonderland, and Lewis Carroll just is Charles Dodgson, then it follows that Charles Dodgson is the author of Alice in Wonderland. Okay, so now we're going to show how we can get the transitivity and symmetry of identity from just the reflexivity of identity and Leibniz's law. So we're going to show how from these two we can derive symmetry and transitivity. So suppose we have a sentence that says E is identical to F. We want to show, without using the rule symmetry of identity, that F is E. Okay. Well, given the reflexivity of identity, we can just simply assert that E is E. So we got this from the reflexivity of identity. And now the idea is that if we look at the second premise, that's like saying if we put E here, then the sentence is true. But since E is F, according to the first premise, if we take out E, so here's us putting E in, and if we put, the second premise says if we put E in there, then the sentence will be true. But given the first premise, E is identical to F, we can go ahead and put F in there, and our sentence will be true as well. So from our premise that E is F, it follows that from the reflexivity of identity and Leibniz's law that F is identical to E. Now we have to show that without using the transitivity of identity law or rule, we can get the same result with just the reflexivity of identity and Leibniz's law. So suppose we have a sentence, premise 1, and we have E is F, and we have a second premise, F is G. We want to show that it follows that E is G. And we have to do this without using either the symmetry of identity as an inference rule or the transitivity of identity as an inference rule. So this one is actually easier than the last one. So if we think of the first premise as saying that E is identical, and there's some blank here. And the first premise says that if we put F in there, then our sentence is true. Well, given the second sentence, that F is G, they're the same object, so we can go ahead and put G in there. So how do we do this? That's basically using Leibniz's law. So from 1 and 2 and Leibniz's law, we get that E is identical to G. Okay, so we've seen how the symmetry of identity and the transitivity of identity can actually be derived from just the reflexivity of identity and Leibniz's law. Thank you very much for watching.